Dear friends, as you know, we are continuing one very important chapter of physics, mathematical physics, that is vector. So this is the lecture number 3 of vector. In the previous lecture, we have discussed about types of vector, and now in this lecture we will discuss about scalar multiplication of a vector and the very important vector addition. Let's start first from scalar multiplication of a vector. One vector, let's take one A vector. This is 2 kilometer east. Let's multiply one scalar with it. The scalar is 5. Multiply one scalar. Then what will the answer? 5 is multiplied with 2. Then this is 10 kilometer east. So what is your conclusion? This is another vector. This is some other vector. So when one scalar is multiplied with a vector, we get another vector of magnitude. Scalar times means scalar into. Scalar times means scalar into. And direction remains same. Is it? Now see. Is it the direction remains same? Let's see. Multiply a negative scalar. Now I multiplied one negative scalar. You see what happened here. This becomes minus 5 into 2 minus 10 kilometer east. So minus 10 kilometer east can be written as 10 kilometer west. This is also another vector. So what you saw here, direction remains same or direction becomes opposite. Direction is opposite if the scalar is negative. Direction remains same if the scalar is positive. But magnitude always becomes scalar times. So the conclusion is, when a scalar is multiplied with a vector, we get another vector of magnitude scalar times, and direction remains same if scalar is positive. Direction becomes opposite if scalar is negative. So this is the conclusion. Again I am repeating it. Listen carefully. When a scalar is multiplied with a vector, we get another vector of magnitude scalar times, and direction remains the same if scalar is positive, becomes opposite if scalar is negative. So this is about scalar multiplication of a vector. So from this one question sometimes comes in exam. So that question is, what is the angle between A vector and MA vector? What is the angle between A vector and MA vector? Where M is a scalar. Where M is a scalar. This question sometimes in some books or somewhere you will find from this concept. What is the angle between A vector and MA vector where M is a scalar? Answer is up to you. This is the homework for you. You will solve this answer. So now let's come to the most important part. I am telling time and again this one, most important part, that is addition of vectors. Let's come now to addition of vectors. We'll discuss addition, vector addition. Suppose I now give you two vectors. You see, one is P vector 3 kilometer east, one is Q vector 2 kilometer north. Now I will tell you, add these two vectors. If you add these two vectors, so P vector plus Q vector. When you add these two vectors, what will be the result? If I ask you this question, what will be your answer? You pause the video here and write the answer, and again you play the video and see the answer. So what is your answer? Your answer is coming like this: 3 plus 2, 5 kilometer, then east north. East north. Maximum students give this type of answer. They always tell this type of answer. So what you did, you add 3 plus 2, that is 5 kilometer. Then east here, north here. You thought, if I leave any direction, then that will feel sorrow. So better I'll write the two directions at a time. Okay. So you wrote the answer like this. Many students always write the answer like this, those who don't know anything about vector addition. It's a common mistake. We cannot add two vectors like this. There are certain rules, certain laws called as laws of vector addition we have to follow to add the vectors. Certain laws are there. So what are the laws now? We'll discuss for vector addition. So now, what are the laws? First law, triangular law. First is triangular law of vector addition. Second is parallelogram law. Then third is polygon law of vector addition. First two laws, they are made for addition of two vectors. First two laws are made for addition of two vectors, and this one made for addition of more than two vectors. More than two vectors. So first we discuss this triangular law, then parallelogram law, then polygon law. And after knowing the law, after understanding the law, you can able to add these two vectors. These two vectors I am keeping here. Okay, this is not the answer. I am erasing the answer. After knowing the laws, then we will add these two vectors. Then the answer will get correctly. So let's first start triangular law. What is triangular law? This comes as a 3-mark derivation also in exams. This is 3 marks derivation in exams, comes in the school exams or in the 11th board exams. So here, first we have to write statement, then we will do the derivation. This is the total triangular law. What is the statement of a triangular law? You first listen the statement carefully. If two vectors are presented by two sides of a triangle taken in same order, their resultant is third side of the triangle taken in opposite order. You can't able to understand anything from this. What I told, you can't able to understand anything. Okay, so let me explain first. Actually, what is this law? Let me explain the statement. Then after explanation, you can able to understand each word of the statement. So two vectors. Now I am taking two vectors. You see, this is a vector. This is suppose P vector. Okay, this is P vector. And I'll add this P vector with the Q vector. Q vector is here somewhere. I want to add the P vector with the Q vector. The name of the law is triangular law. So I have to make a triangle. The total law is confined in a triangle. But how I will make a triangle? I have to bring this Q vector to P vector to make a triangle. Okay. So now bring Q vector to P vector. If I bring Q vector to P vector, you see this is the Q vector. Vectors can shift parallelly. Vectors can shift parallelly. I had told you in the first lecture. then there is no change in vector. So now let's shift it parallelly. How is the q vector? You see, almost this is same now. This is the q vector. Vectors can shift parallelly. Okay, if this is q, then this is q. Then you are thinking that why sir is drawing this q vector here? Why not here? Here I can also draw parallelly. No problem. Why only there? Why not here? So now I am explaining you the statement from the starting, word by word. Listen. If two vectors are presented by two sides of a triangle, taken in same order, that is important. Same order means what? Tail, head, this is called same order. Same order. When you stand in prayer class in your school, all students stand facing towards the stage of the prayer place. Towards the stage. If any one student will stand keeping his back towards the stage, then you will tell he is standing in different order, opposite order. Order means, you see, here order means what? Tail, head. This is called order. Keep in mind. Tail, head. But what about your q? If you take this q, if suppose that q in place of this, instead of placing here, if I place here, then what will happen? These two will not be in same order. This is not enough statement. You see, they will not be in same order. Head, tail, head. They are in order? No. But these two are in order. So instead of this, we will place here. To only keep the two vectors in same order. Tail, head. But here, not in same order. So we will not place the q here. Will not place q here. Okay. So now p and q both are in same order. Again, now come to the statement. If two vectors are presented by two sides of a triangle taken in same order, their resultant is the third side of the triangle. See the third side. This is the third side of the triangle. Third side of the triangle taken in opposite order. Where I will put the arrow in this? To which side I will give the arrow? In this resultant. This resultant is r vector. P vector plus q vector is equal to r vector. But where I will put the arrow? Towards this side or towards this side? To which side I will put the arrow? You see? How will know? To which side I will put the arrow? Opposite order. The last some words in the statement. The third resultant is the third side of the triangle taken in opposite order. Taken in opposite order. Tail, head, tail, tail. Because that one should be in opposite order. Tail, head, tail. So this one is correct. So we'll put the arrow in this direction. Not this one. Now you could able to understand. Geometrically now I think you could able to understand that which one is the resultant in a triangle. If you are making the two vectors as two sides of a triangle. So again I am telling you, if two vectors are two sides of a triangle taken in same order, then the resultant is the third side of the triangle taken in opposite order. If you could able to understand, now I am giving one question to you. See, suppose you see the here, so here, 1, 2, 3. This is the question to you. Which one is the resultant? Pause the video, think the answer, then again you play the video. Which one is the resultant? See, which one is the resultant? How will know? Now I am telling you the answer. You have to check which one is in opposite order. Which one is in opposite order? You see, tail, head, tail, head, tail. Tail, head, tail. So which one is the resultant? I know you told the answer 1. So you are correct. Those who are thinking the answer 1 is the resultant. Good. Then will come another question. See. Another question you see. So this is also another question. This one. 1, 2, 3. Which one is the resultant? Again pause the video and you think the answer. Again you play the video. Which one is the resultant? Answer is coming to your mind. 1, 2, 3. Which one is the resultant? If the answer is coming 1 or 2 or 3, then you are wrong. Here, no resultant. No resultant here. Why no resultant? Because tail, head, all are in same order. No vector is in opposite order here. So no resultant here. So you could able to understand the triangular geometrically. Geometrically we can able to draw the resultant. Now let's come. How will find the magnitude of the resultant and its direction? After drawing geometrically, we want to find the magnitude of the resultant and its direction. We know the magnitude of P vectors, that's P, it's given to us. Q vector magnitude is Q, and the angle between P and Q also will be given to you. And the question will be to find the resultant magnitude as well as the direction. This is the derivation. And what is the angle between P and Q? Here you can draw the find the angle. This will not be the angle. This cannot be the angle. Why? Because they are joined at tail and head. I have told you how to find angle between two vectors when they are joined tail. For that I extend P. I extend P in this direction. This is P vector. So this one is the angle between them, theta. This one is the angle between them, theta. Okay. So we want to find magnitude of R vector, magnitude of resultant. So that is the first challenge to us. First we will find its magnitude. How will we find the magnitude? Magnitude means what? Length of a vector. I have told you in the first lecture, length of the vector is magnitude. Okay, length of the vector. Its length is P, its length is Q, its length is asked here. How will I find its length? Only you know one formula in triangle, and that only valid for a right angle triangle. That is only valid for right angled triangle. But here there is no right angle triangle. How can you get this R vector mod, means the length of this side? How can you get? Here is no right angle triangle. If you will get one right angle triangle, then we can apply Pythagoras theorem. But we are not getting any right angle triangle now. But we can get to a right angle triangle. We have to bring a right angle triangle. How? By construction. We'll do construction and we'll find one right angle triangle. You see, this is the construction. From this to this, let's draw a perpendicular. This is A, this is B, this is C, this is E. I left D, okay, which will later help us. So A, B, C, this is E. So now this is the right angle triangle. We can apply Pythagoras theorem. A, E, C right angle triangle, where R vector is the hypotenuse. But when you apply, we know this P, its length is P, we know this length is Q, but we don't know B length. we don't know C length. We have to find out B and C. And how will find out B and C? For that we have to use, now you see, in triangle BEC, cos theta, because you want BE first, cos theta. Cos theta equal to BE by BC. So implies that BE is equal to BC cos theta. But what is BC? BC is Q. Q cos theta. So we got B. Then what will find? Then we'll find C. How will find C? Again in the same triangle. Sin theta. Again in the same triangle. Sin theta is equal to CE divided by BC. So again C is equal to BC sin theta is equal to Q sin theta. So we got now C is equal to Q sin theta. So you got B Q cos theta, C is equal to Q sin theta. But we want AC. How will find AC? Now we'll use Pythagoras theorem. Okay, so now using Pythagoras theorem. C. Using Pythagoras theorem in triangle AEC. Use Pythagoras theorem here. AEC triangle, that is AC square is equal to AE square plus EC square. So implies that AC square is equal to AE. I am splitting A into AB plus B. AB plus B square. Then plus this is EC square. Now you open this A plus B whole square. Now open this A plus B whole square. So if you open, what will get here? So AC square is equal to AB square plus BE square. So plus, or we directly put the values there. Directly put in place of AC. AC is what? R. R square. What is AB? That is P. What is B? C. B is Q cos theta. Q cos theta. So this is square. After putting values, we will open this A plus B whole square. Then EC. C, I just changed EC. So C, that is Q sin theta. Q square sin square theta. So imply that R square is equal to P square plus Q square cos square theta. I use A plus B whole square formula. 2PQ cos theta plus Q square sin square theta. So imply that R square is equal to P square plus Q square you take common. If you take Q square common, what you get? Cos square theta plus sin square theta plus 2PQ cos theta. But cos square theta plus sin square theta. What is this? Cos square theta plus sin square theta, that you know in trigonometry. Cos square theta plus sin square theta equal to 1. So imply that R square is equal to P square plus Q square plus 2PQ cos theta. So if you write R is equal to root under P square plus Q square plus 2PQ cos theta. So this is the formula of magnitude of resultant. You have to mug up this formula because in all chapters this formula is required. In all chapters you will face vector addition. You may say kinematics chapter, you will face vector addition, velocity, you will add. If you say laws of motion chapter, you will add forces. If you go to 12th class, you will add electric vector, you will add magnetic vector. So everywhere you have to use the vector addition formula. So this formula you have to remember. R equal to P square plus Q square plus 2PQ cos theta root over. Now you tell me the formula with me. R is equal to P square plus Q square plus 2PQ cos theta root over. So this is about the magnitude of the resultant. Now we'll come to the direction of the resultant. Where is the direction of the resultant? Direction means angle. If you know P vector, if you get that the resultant makes how much angle with the P vector or with the Q vector, then we can draw it, no problem, because you know this line. We can draw if you know it makes how much angle with the P vector. So let's take this angle as beta. So this is the direction. This is the direction beta. How will find beta? Come to the direction now. How will find this beta? In triangle AC, tan beta. Tan beta is equal to CE divided by A. C is Q sin theta and A is AB plus BE. So this is Q sin theta divided by AB is P and BE is Q cos theta. So this is the tan beta formula. You have to remember also this formula to solve the questions of vector addition. To know the direction of the resultant, you have to also remember this formula. This is magnitude, this is direction. After that, this direction also you can able to find out in another way. You see, this direction you can also find out in another way. In which way? You can use sin beta here. Sin beta is equal to, that is, sin beta is, see here, CE. CE divided by AC. But what is CE? CE is Q sin theta and AC is R. You can use also this formula, sine formula, to find the angle. But the problem between them, now the difference between the two is, here to find direction you need the magnitude of the resultant. But here without calculating R, you can also find the direction. So this is maximum used than this. So this is about the magnitude and the direction of the resultant. But as theta is here, so now let's come and discuss the special cases. Now let's come to the special cases. So special cases like theta is equal to 0. First we will discuss about theta is equal to 0 when two vectors are parallel. I am writing the resultant formula here because this one will use repeatedly 2PQ cos theta root over. So first come to case 1. Okay, case 1 first come. Case 1 is theta is equal to 0. Theta 0 means the two vectors are parallel. The two vectors are parallel means one vector is like this, A vector, another vector is like this, suppose B vector. Two vectors are parallel now. So in this case, what is the resultant? R is equal to, here you put in the formula, theta is equal to 0. Put what you are getting? P square plus Q square plus 2PQ cos 0. Value of cos 0 is 1. You know in trigonometry, it's root under. So P plus Q whole square root over. So this is P plus Q. What happens to the resultant? Simple addition of the two vectors. Simple addition, P plus Q. The magnitude is equal to simple addition of the two vectors P and Q. Okay, now come to the practical example. Here, see this vector is, suppose this is, let's take 5 km east and this is 2 km east. two vectors there. One is 5 km east, B vector is 2 km east. If I add them, what I will get? The magnitude is just the addition of the magnitude of them. So 5 plus 2, P plus 2. So this is 7 km. Simply 7 km. But where is the direction of the resultant? Where is the direction? To find direction, now use the direction formula. 2 beta q sin theta by P plus q cos theta. But in place of theta we will put 0. What is the value of sin 0? Sin 0 is 0. So tan beta is 0. So if tan beta is 0, then beta is equal to 0. That means the resultant makes 0 angle with a vector. 0 angle with the p vector means here with a vector. But I write here p vector better. P vector and q vector. Now the resultant is making 0 angle with the p vector. If 0 angle with p vector means same direction. So length is 7 km, you see. Long, because it's 7 km. 5 plus 2, 7 km. And direction is same as p, means towards east. So this is your resultant. This plus this is equal to this. If you will not know anything about vector addition and this type of addition you will get, then by default the answer will be correct. Because you will add the two magnitudes, 7 km east, so direction is east. If somebody don't know about the triangular law and will get this question, by default the answer will be correct. Because it's the most easiest one. If two vectors are in same direction, their magnitudes are just added. And the direction is the same as the p vector here. Means also same as q vector. Now let's come to the case 2. Case 2, I am doing that. Theta is equal to 180. Means they are anti-parallel. You see, I am making here, they are anti-parallel to each other. If anti-parallel, what happens? So this one will be cos 180. So it's minus 1. Cos 180 is minus 1. So this one will be minus. This one will be minus. Means the resultant magnitude is the subtraction of a 2. But the question comes, P minus Q. Why not Q minus P? Why not Q minus P, only P minus Q? Why is it like this? So you can write here P minus Q whole square. You can also write Q minus Q whole square. That doesn't matter. But always remember, which one is greater, you have to take that one first. So here P minus Q means I assume P greater Q. I assume here P greater than Q. That I assume. So if two vectors are given to you, always you take the greater vector as P vector. The greater vector. Always do greater vector minus the smaller vector. So here this is P, 5 km east. This one, question I changed here. This is 2 km west. Now I change the question. 5 km east and 2 km west. They are anti-parallel to each other. Then the resultant will be not 7, 5 minus 2, that is 3 km. 5 minus 2 is 3 km. So that is 3 km. But where is the direction? The direction will be along the greater vector. The direction will be along the greater vector. Okay, which one is greater vector? E. So this one P vector is the greater vector. So the direction is towards east. So here the direction is east. Now understand, the direction of the resultant will be along the greater vector. You see the same tan beta q sin 180. If you put here sin 180 is 0. So beta equal to 0. So when two vectors are like this and you are doing the addition, two are anti-parallel to each other, the resultant is magnitude is just a subtraction of their magnitude and direction is along the greater vector. Okay, greater vector is towards east, so direction of resultant remain towards east. So this is about theta 180 degree. Now come to the third case, that is different. Theta is equal to 90 degree. Then what happened? Now let's see. Theta is equal to 90 degree. Case 3. If theta 90 degree, then what happens to the resultant? P square plus Q square plus 2PQ cos 90 root over. Here I put, but value of cos 90 is 0. So it is simply P square plus Q square root over. This is the magnitude of the resultant. And what about the direction? Tan beta Q sin theta. Theta means 90 by P plus Q cos theta. But sin theta is 1, so that is Q. But cos 90 is 0, so this part tends to 0, this part tends to 0. So this is P. Tan beta is equal to Q by P. This is about the direction. So let's see geometrically what is the situation. This is P vector, this is Q vector. Okay, so this is P, this is Q. Both are perpendicular to each other, 90 degree angle. This one is the resultant. Arrow to which side? Towards Q or towards this lower side? Tail, head, tail, head, head, tail. So towards this. This is the resultant. If somebody don't know the triangular law, don't know this formula, okay, also can do it very easily because it's already right angle triangle. So what is the length of this arc? P square plus Q square root over. That also comes here. And what about the direction? This direction is beta. See, this direction is beta. Tan beta is equal to Q by P. Simple. In right angle triangle, what simple formula we are using? That one here. So this is about the 3 cases of triangular law. But I have told you, if after knowing this triangular law, after knowing the law of vector addition, what question I have given you from the starting, that question we can able to solve. What question I have given you? What I have remembered, I think the question is like this. 3 kilometer east and 2 kilometer north. Now we'll do this question. Okay, we'll add them. Whether we'll see whether the answer is coming 5 kilometer northeast or not. Okay, we'll check it. Now see how we'll do it. So this is P vector, that is east. I'm drawing P vector east. This is 3 kilometer. This is P. 2 kilometer north. 2 kilometer north. This side is north, you know, the offside is north. 2 kilometer north. So this is Q. Which one is the resultant? The resultant is the third side of this triangle. So this is the resultant. This is the resultant geometrically. Okay, but how I'll find its magnitude? These two vectors are perpendicular to each other. Theta is equal to 90 degree. You can directly use the formula to find the resultant. Directly you can use the formula to find the resultant. P square plus Q square root over. Just before I told you, if theta is 90 degree, resultant is P square plus Q square root over. So here P is 3 square, Q is 2 square, so it's coming 9 plus 4 root over, so root under 13. This is the magnitude of the resultant. But what about the direction? Direction is this, beta. Tan beta is equal to Q by P. In special case also I have told you Q by P. So Q by P means that is 2 by 3. So this is tan beta, or you can write beta equal to tan inverse 3 by 2. You can show the direction here, you can show beta angle here, that will be sufficient. Or if you want, you can write, because this side is east and this side is north. So that is north of east. representation. I have told you how to write north of east. This is east side. So from east you will go towards north, bit angle, north of east. So this is the direction of the resultant. Now you compare with your answer without knowledge of a triangular law, and you now see the answer with the knowledge of a triangular law. Without knowledge of triangular law, what is your answer? 5 km. But actually the answer is root 13 km. I left the unit here, root 13 km. And the direction is this. We can't able to get it because it is not our known value. You can leave it like this, tan inverse 3 by 2, no problem, nobody will cut your mark. So in this way we can add two vectors. So this is about triangular law. Now we come to the next law of this chapter. Next law is parallelogram law of vector addition. Parallelogram law of vector addition. Parallelogram law. Again, this law also starts with a statement. What is the statement of this parallelogram law? If two vectors, it is also meant for addition of two vectors. If two vectors are presented by two adjacent sides of a parallelogram, then their resultant is the diagonal of the parallelogram starting from their common point. You can't able to understand the statement. Okay, let me explain you what's the statement. So this is the P vector and this is the Q vector. What we will do? We will bring the Q vector and we will make it in contact with the P vector to make parallelogram. Okay, so now I will bring the Q. To which side I will bring the Q? To this side or to this side? Let's see. Let's bring. This is the Q. Then the question is coming to your mind, sir, why you didn't take to this side? Also you can take to this side. This is Q. You can also take to this side. This is Q. But which one will keep? Which one will keep? This one is correct. Now here, not this one. Here order not matters. These two are in same order. But here order not matters. After that, we need also one common point of them. From where they start. From where they start, we need that common point. Because in statement there is a common point. Here order not matters. Rather they behave like two adjacent sides having a common point from where they start. They simultaneously act. When two vectors act at a point simultaneously. This also is in the statement. Okay, simultaneously they act. Then these two vectors act simultaneously at this point. This is P, this is Q. Simultaneously at a time. Simultaneously means at a time two vectors act at a point P and Q. Then for the statement it telling, if two vectors act at a point simultaneously and represented by two adjacent sides of a parallelogram. If you get two sides of a parallelogram, can we draw the complete parallelogram? You just recall your construction of lower classes. Can you draw the parallelogram? Yes. Let's draw the parallelogram from this to this. Now from this is the side, then this is the side. I think the parallelogram is complete. Okay, it's a perfect parallelogram now, you see. Okay, so this is the parallelogram. If this is the parallelogram, see, now let's name it A, B, C, D. Okay, so A, B, C, D is the parallelogram. Taking the two vectors, I draw one parallelogram. Which one is the resultant? Which one is the resultant? I am repeating again the statement. If two vectors acting at a point simultaneously are presented by two sides of a parallelogram, then their resultant is the diagonal of the parallelogram starting from their common point. This parallelogram has how many diagonals? One is AC, one is BD. One is AC, one is BD. This diagonal has two. This parallelogram has two diagonals. But which diagonal will take? Again you recall the law. The resultant is the diagonal of the parallelogram starting from their common point. Their common point is which point? This point. So this point. From this point which diagonal start, that is the resultant. So this is the resultant. Again I repeat, the diagonal starting from their common point. Don't confuse about this diagonal. This is the common point of them where they act simultaneously. So that is the resultant. So geometrically, hope you could able to understand the resultant. Let's check. Now I will give you one question. So suppose one vector is like this. You see, suppose one vector is like this. This is some A vector and one vector is like this. See, one vector is like this. I will not draw them because they should act on a point simultaneously. So this is one vector, B vector. The two vectors, A vector and a B vector, they act on a point simultaneously like this. Draw the resultant. How will you draw the resultant of the two? How will you draw the resultant? What I told you. After getting the two sides, immediately construct one parallelogram. How will you construct the parallelogram? You see. Construct the parallelogram. You can construct the parallelogram, you see, better than me. This is the parallelogram. Okay. You can construct the parallelogram after getting the two sides. You will construct the parallelogram. Which one is the resultant? The diagonal starting from their common point. Common point means which point? You see, which point is the common? This point is the common. From the common point we start, that is the resultant. So this one is the resultant. Now you got it? How we will find the resultant? By parallelogram law. You will construct the parallelogram and the diagonal which start from the common point is the resultant. When the triangle is like this, this one, and when the triangle is like this, then this one. Not triangle, when it is to this side, this is the resultant, when to that side, this is the resultant. But sometimes some students misunderstood and write the wrong statement, that the resultant is the wrong statement. They write like this. Remember, you will not do that one, that mistake. The resultant is the longest diagonal. That's totally wrong. You saw now? Here the longest diagonal, it's right. By default this one will be correct. But here is it the longest diagonal? No. But this is the correct answer. Here it is the shortest diagonal. So don't write in the statement that the longest diagonal is the resultant. No. Rather the correct one is the diagonal which start from their common point. So geometrically you understood what is parallelogram law. Then how will find its magnitude? How will find its magnitude? We know P vector, we know Q vector. How will find its magnitude? So again we need one right angle triangle, and if this is Q, then this is your Q vector also. Okay, so you have to draw one right angle triangle, Pythagoras theorem, then use, then you find everything is same as triangular law. Everything is same as triangular. You see how I am converting this parallelogram law into triangular law. This Q is same as this Q. If we erase this portion, you see, if I erase this portion, so now it becomes your triangular law, which is just I discussed before some minutes. Same as this triangular law. Next part of a derivation is just you will copy from the triangular law what I did. For only to copy easily, I took the perpendicular here. What perpendicular I choose? I choose the perpendicular here as E, so that you can able to copy. All alphabet also same, because your one D is used. For that in triangular law I have taken E. You just recall why sir had left that D alphabet. Okay, so because the triangular law what I had written, the same thing also will write in the parallelogram law. Magnitude, then direction, then special cases, everything is same. So this is all about the parallelogram law. But the question is coming to your mind. Triangular law is meant for addition of two vectors. Parallelogram law is meant for addition of two vectors. Parallelogram can be converted into triangular law. Triangular law can be converted into parallelogram law. Then why two laws? Why two laws? Why these people are creating burden to students? Why two laws? So what's the basic difference between them? If two vectors are one by one, first this one, when this vector ends, then this one, then you will use triangular law. Remember, when they act one by one, then triangular law, they are in same order. But when two vectors act simultaneously, when two vectors act simultaneously, then parallelogram law. Can you mark the basic difference? If two vectors act one by one, then triangular law. If they act simultaneously at a point, then parallelogram law. But you can convert this law to this law and this law to this law. You can convert, but directly you can apply triangular law if they are one by one, and directly you can apply parallelogram law if they are acting simultaneously. So this is about triangular law and parallelogram law and how two vectors will be added. But one important thing I am telling you, one important concept I am telling you here about this vector addition. When two vectors are added, the result is a vector but lie in the same plane of the two vectors. This is important concept. This is important concept of today. This is concept of this lecture. When two vectors are added, if P vector is added with Q vector and you got R vector, all the three vectors must be coplanar. This resultant must lie in the same plane of these two vectors. So all the three vectors will be coplanar if they are added. When two vectors are added, the resultant lie in the same plane of the two vectors. If P is on this whiteboard, Q is on this whiteboard, also R is on this whiteboard. If P is here, Q is here, R is not coming like this. R is not coming like this. R is lying on the same plane. Remember this one. This one will help you to solve many questions. This is the concept. When two vectors are added, the resultant is also a vector which lie in the same plane of the two vectors. Means all three are coplanar. Now the question is coming to your mind. After reading this addition of vectors, whether we are using this in our day-to-day life, any place, anywhere, or just we are reading like this to appear exam. Dear students, I want to tell you one thing. What you learn in physics, everything we collect, or our scientists, everybody collect it from the nature. If it is not happening in our day-to-day life, if it has no use in the day-to-day life, that must not be in physics. What happens in day-to-day life from the nature, that come to the physics in mathematical form. So this is only the language of nature. This is only the law which is brought from the nature. So everything must happen in the nature. So can you tell me where this vector addition is applied in day-to-day life? Where this vector addition is applied? Can you tell me any practical example? Can you think? You pause the video here and think where it is applied. Then I am showing you the device where it is applied. Okay, now I am showing you the device. You can see here this one, very small one I have made for you. Have you seen this device anywhere? This is called as catapult. Okay, a very small, very cute catapult I have made. So this is called a catapult. Those who have not seen, you must have seen that in one Hindi movie. Okay, that song Didi Teri Deor Divana. Okay, this one, very famous catapult you have seen. So what happened in this catapult? So in this catapult you see two forces. So this is the object. See two forces. So this one, through this one force act, through this one force act. Both forces act in the backward direction, you see. Backward direction, both forces act. So simultaneously, you see, they act also simultaneously. They act also simultaneously here at this point. Okay, two forces act simultaneously. This is your catapult. Okay, so two forces, one force like this, one force like this. Two forces act at a point simultaneously. This is F1 force, this is F2 force. Simultaneously they act at this point. This is the object. Okay, this is the object. They simultaneously act at this point. When they simultaneously act, can you draw the resultant of these two? Can you draw the resultant of these two? Yes, you can draw. How will you draw the resultant? You see, you extend this P1 in the forward direction. I am extending by solid line. I am doing a different color. So extend F2. See F2. This is F2. Okay, this is F2 vector. F1 and F2. So where is the resultant? The resultant is this one. You have to make a parallelogram law. You have to make parallelogram. You see that you have to make parallelogram here. This is the parallelogram. Just parallel line to this. Just parallel line to this. Okay. Can you able to make parallelogram? Now this is the parallelogram. Which one is the resultant? The resultant is this. The resultant is the diagonal will start from their common point. This is the resultant. This blue color. Okay, so this is the resultant. I extended F1 vector to this side. This is F1. F2 vector to this side. This now act at this point. So this is the resultant. The diagonal starting from the common point. So this is the net force. I am not writing R here. I am writing F here. Net force. This is F. Vector is the net force. F1 and F2 are added and we are getting F force. F vector. Okay, but F vector is not helping us to send this object. F vector is not helping us. F vector is acting towards me. Then when F vector is acting towards me, it gets the reaction force. You know, in Newton's third law, every action has equal and opposite reaction. So you are getting reaction here. Due to that reaction, see, we said you are getting the reaction. You are getting the reaction just opposite to it. Okay, you are getting the reaction just opposite it, and the object fly along the reaction force. This object fly along the reaction force. You see, this object is fly along the reaction force. Okay, so this is about the example catapult, which use parallelogram law of vector addition. Not only this, I am also giving you another example. Flying bird, but sorry, I can't able to bring one flying bird to you. Okay, so flying bird. In flying bird, what happens? Though I am not good in drawing, so this is the bird. Suppose flying bird. These are the wings of the bird. You see the wings. What happens? The bird apply force like this. If you want to go up, apply force like this. If you want to go to front, apply the force like this. Apply the force like this. Okay, so apply the force by the help of the two wings. Apply the force by the help of the two wings to go in forward direction. Okay, to go in forward direction, apply the force like this. Let's make it a radar. Okay, so it's a radar of the bird. So if these are the two forces, then what happened? Here, it's resultant again. You extend here, you extend here. On air, it apply the force. These are the two forces. Then we have to construct a parallelogram. Then this is the resultant. Then it's reaction force. It apply the forces to air. This apply the forces to air, and this is the net force applied on air. Then air gives the reaction force. Air gives the reaction force like this. Then the body can able to fly due to the reaction force. So this is the practical example of triangular law and parallelogram law and addition of vectors. Thank you.